So today we are going to discuss these questions. Okay. Just a moment. Okay. So tell me in which question you have doubt. Question number 1, I think it is very clear. I think we had done it in the previous session also.
Yeah, we discussed till question number 20. So,
Okay, but some questions were left, I think.
yeah,
Okay, so can we discuss all questions?
sure.
Okay. So first one we did. In the first one we have to find the ratio of distance and magnitude of displacement. So distance will be this one, okay, from A to B. That will be the arc, and the displacement would be that one, okay, the straight line between A and B, okay.
Arc length, right?
Yeah, arc length is the distance and displacement is the straight line,
Okay.
this straight line.
The displacement will be the straight line.
Yes, this one, and this will be a these are the radius. So as it is 60 degrees, so these two angles will also be 60 degrees, isn't it?
Yeah.
So that will be the radius. That means that will be an isosceles triangle, sorry, equilateral triangle. So that distance displacement would be r. Displacement will be small r, okay. And what will be the arc?
Arc length would be the
Either you calculate it theta by 360 into 2 pi r, okay. So theta is 60 degrees, 60 by 360 into 2 pi r, okay. So that is cancelled, so that is pi r by 3. Got it?
yes, it's like the 16.
So that will be distance. So you need to find the ratio of distance with displacement. So distance over displacement will be, distance is pi r by 3 and displacement is r cancelled, so that will be pi by 3, okay.
Yeah.
Got it? So your option number 3 is the right answer. Got it?
Okay.
Okay. Now in the second question, it is very simple. The angular acceleration of a body moving along the circumference of a circle is, tell me which will be the right answer. See the angular
Tangent to its position.
no. Angular acceleration is always along the axis of rotation. Just remember it.
Always.
Yeah. Angular acceleration is always along the axis of rotation. Okay?
Okay.
Got it? Okay. Now third one. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The coefficient of static friction between the body and the floor is 0.15. Okay, which principle will work here?
We'll just use mu into n, right?
Yeah. So whenever your mass into acceleration, mass into A max in this scenario will be equal to the force of friction. Then only your body lying on the floor of the car remains stationary. Okay?
Yeah.
So that will be the condition, that its force will be equal to mu mg, and force will be mass into A max. Okay? mm will be cancelled, so that A max will be equal to mu g. Mu is 0.15 and g is 10, so that will be 1.5 meter per second square. Okay?
This question was easy.
Yeah. So the option 2 is the right answer.
So, but why did you? Okay. But how do you know that there would be the maximum acceleration when it's mu mg?
Yeah, the maximum acceleration occurs when the friction force equals the force needed to remain that body stationary. That is the condition.
Can you repeat?
See, the force maximum acceleration occurs when the friction force equals the force needed to the body lying on the floor to make it stationary. If the body is stationary, so the force will be equal to maximum acceleration with mass will be equal to the frictional force. If they are equal, then that will be the maximum acceleration. Okay? You can remember it that maximum acceleration to prevent the body in motion, so that will be mu g. Okay?
To prevent. Then can you repeat it? I'll just write it down. Maximum acceleration is equal. When there is maximum acceleration, it will always be equal to mu mg.
Mu g, yes. Maximum acceleration will be equal to mu g to prevent the body, or you can say to keep the body stationary on the floor of the car. Okay?
1 second. Keep body stationary on floor, right?
Yes.
So, but what if there's also component of pseudo force acting downwards? Will you consider that, or will it still be the maximum?
See, the body is also having the same force, whatever car is having. Okay?
No. I'm saying if there's a scenario in which there's a pseudo force is acting on it, so in that case, would it still be equal to this, or?
In every case. That is a concept, you have to remember it.
Okay. In every case.
Yes.
But when it's what if it's a station which is attached with a string or something like that, and the string is being moved like a pendulum?
String is a different concept.
Okay. When it's like a car or object like
Yeah.
that, only that.
An object is lying in the car, then only this will work. Because if it is attached with the string, then tension will also come into the picture. Okay?
Yeah.
Okay, now fourth one. Just tell me the answer, it's very simple.
Okay, so it won't work with pseudo force also, because pseudo force will come into picture.
Okay, just now do fourth one. Tell me the answer for this. An object follows a curved path. The following quantities may remain constant during the motion. If it's a curved path, okay,
So it's a curved path, what is it for it will remain constant? Speed, velocity. magnitude of acceleration
Yeah.
will remain constant.
Magnet.
That will be one.
Hmm.
And speed.
Yeah, speed also may be the constant because velocity will change each and every time. Okay, because velocity will be the tangential. So here its magnitude may be the same, but its direction is always changing, isn't it?
Yeah.
So that cannot be same, and same case with the acceleration because it's a vector quantity, so that cannot be same. Okay.
Yeah.
Okay. So option 1 will be the right answer. A and D. Speed and magnitude of acceleration, that will be remaining constant. Okay, just now do fifth one.
That because it is increasing its speed at the rate of 3 meters per second. It's net acceleration.
Fifth one is also very simple. See, the net acceleration will be what? It will be a vectorial sum of centripetal acceleration with tangential acceleration. Okay, and they always perpendicular to each other, isn't it?
Yeah.
So A net will be equal to A centripetal plus A tangential square root. Okay.
Yeah.
So can you calculate?
But how do you find out the tangential acceleration on this?
Tangential acceleration is dv by dt.
Okay.
And what is dv by dt? It is given.
But what is the 3 meters per second in this case, sir?
It is dv by dt. It is
No,
dv by
that's the tangential acceleration.
Yes.
How do you know that?
It is given here.
It's not given.
It is increasing its speed at the rate of 3 meters per second square.
Yeah, actually, how do you know if it's the tangential acceleration or like is it the?
Because it is given as 3 meter per second square. So meter per second square is the acceleration.
No. Is it the tangential acceleration or is it the centripetal acceleration? How do you know that?
It is tangential. Centripetal acceleration will be given by, because whenever car is on a circular path, so he is saying car traveling at 20 meter per second on a circular road of radius 100 meter. So it is increasing its speed at the rate of 3 meter per second square. So that will be only tangential acceleration. So tangential acceleration will be 3 meter per second square. Centripetal acceleration, you need to find it. So AC will be what? V square by R.
Tangential acceleration is always as a tangent, right? Imagine if the car is at this position, then the tangential acceleration will be moving like that, to a tangent to that position.
So the magnitude of tangential acceleration is given. That is 3 meter per second square.
No, how do you know that it's the tangential one and not the centripetal?
Centripetal will be given by AC equal to always the speed, always it will be tangential. Centripetal you need to find it by the formula V square by R. Okay. So what is V? V is.
What's this formula, sir? V square by R.
It is centripetal acceleration, yeah. What is centripetal force? mv square by R.
When did we learn that?
Yes. Centripetal force is mv square by R. So what is V square by R? It is A, acceleration. Okay. So V is 20 into 20 and this is 100. So that will be how much? 4.
Yeah.
Okay. So what will be the answer in it?
So, but when did we learn this formula?
Once we learned centripetal acceleration, from where it came? It came with the centripetal acceleration. Centripetal force is mv square by r. So once mass is multiplied with the acceleration, it becomes force. Okay. So before centripetal,
Repeats are not able to understand.
yeah. What is force? Force is m into a.
Yeah.
If you compare this mv square by r with ma, what happens? A equal to v square by r.
mv square by r by ma. Okay. But where did you get it is equal to mv square by r then?
mv square by r, we learned it at initial stage.
Okay. Okay, sir.
So centripetal acceleration is 4 meter per second square. So A net will be 4 square plus 3 square square root. So that will be 5 meter per second square. Okay. So A net is 5 meter per second square. Third option is the right answer. Okay.
Okay.
Should we go to the next?
Yeah.
Okay, sixth question. It's a very good question. Just try to answer it. It is a conceptual question. Yes, are you understanding it or not?
Yes.
Okay, so what will be the answer?
The answer for this will be here. One second. Almost done.
There are radial and tangential acceleration.
None of them should be equal to 0. That's what I understand.
What is tangential acceleration? Tangential acceleration is dv by dt.
Yeah.
Okay. So that means it is rate of change of velocity.
Yeah.
Okay. So see, AR should not be 0 in any case,
But
because
none of them should be equal. Right?
because
Even if tangential acceleration is 0, it'll just collapse. So none of them should be equal to 0.
if tangential acceleration can't it 0? Can't it be 0?
Okay. If tangential acceleration is 0, then it will just move towards the center.
Why? I thinking that they both are balancing it. No,
Okay. No.
they are not balancing. They both are not balancing the body. Okay.
So, but even if it's not, even if tangential action is 0,
If
then
it's
what will be the force pushing it forward then?
if there is no change in speed, then what will be the tangential acceleration? It may be 0. Okay. Tangential acceleration may or may not be 0. Isn't it?
Yeah.
So AR is not 0 in any case. So option C is also right and D is also right. AT may or may not be 0. Okay.
Okay. But if AT wave may not be 0, it can still move. Then even if AC's wave may not be 0, it can still move.
Tangential acceleration is rate of change of velocity. So there may be, it may be 0 or may not be 0.
Okay.
Okay. Next one. So C and D both are correct options. So option 4 is the right answer. But AR cannot be 0. If AR is 0, then there will not be any circular motion. Okay. Okay, do question number 7. Try to do it. Whatever is given, just write down. Radius is given. So R is 0.3 meter. Linear speed is given. V is 2t in t second and v in meter per second. Find out its radial and tangential acceleration at t equal to 3 seconds. So you need to find AR, you need to find AT. What is AT? AT is dv by dt.
Yeah.
So that will be 2. If you differentiate 2t with respect to t, you will get it 2. Okay. And even you need to find other acceleration, because 2 is the option only in third option. Okay.
Okay.
But you can also find AR. So AR is V square by R, isn't it?
Yeah.
And at t is equal to 3, what is the value of V? At t is equal to 3, V would be 6, isn't it?
Yes.
So 6 square divided by R, the R is 0.3, so that is 36 divided by 0.3, so that will be 120 meter per second square. So option 3. Got it?
Yeah.
Okay. Now the next question is also a particle move in a circular path of radius r with an angular velocity. Now this time angular velocity is given, where a and b are positive constant t is time. The magnitude of the acceleration of the particle after 2a by b time. You need to find the velocity of the particle after this given time 2a by b. Just try to do it.
Okay, sir.
Try it your own. If you're not able to do it, just will do it. I'll give you a hint. First of all, you calculate angular acceleration, because angular velocity is given, so you can find angular acceleration.
Okay, sir.
And after finding angular acceleration, you can find tangential acceleration. Do you know that relation between tangential acceleration and angular acceleration?
Yeah, I think we looked at.
Yeah, what is that?
Let me check again.
tangential acceleration is alpha r. What is alpha? It is angular acceleration. Okay.
Yeah.
Do you remember it?
Yeah, I remember it.
Okay.
This paper is very lengthy.
Yes.
Okay, sir. Almost last year.
Is that understood or should I do it?
One second, sir. I just made this clearer. Yes, sir. The answer is my answer is not matching any of the options.
Okay, no issues.
I got 1 minus 2b into r divided by 2.
Okay, we'll do it for you. First of all, we'll calculate alpha. From there, alpha will be d omega by dt. So that will be minus b. So what will be at? At will be alpha r.
Why will it be minus b, sir?
If you differentiate it,
A and b are constants, right? So we can just remove.
if you do differentiation, differentiation of a will be 0, differentiation of minus bt will be minus b.
Yeah, okay.
Okay.
Get it.
So that will be
So
80.
remove A as
What is AC or AR? Will be V square by R. Okay.
Yeah.
What is V? Or it is also equal to R omega square. Okay.
Yeah.
So just keep the values. R is capital R, omega is A minus BT, and at a particular moment of time, the time is given as 2A by B. So we'll calculate it, will by putting at the place of T, we'll put 2A by B. Okay. That is whole square. BB cancelled. So that will be R. A minus 2A is minus A square is A square. Isn't it? So that AR is R A square. So now A net will be equal to AR square plus A T square under root. So that is R square A to the power 4 plus it is B square R square. Now R square is common. So after rooting it becomes R. So that will be A4 plus B square. So that will be its net acceleration. Okay.
Yeah.
Okay, good. Now understood the concept. It was quite simple.
Okay, sir.
Okay,
Actually, I did a differentiation on that was my issue.
okay. Now just do this ninth one. That is also very simple.
This formula for simple acceleration is d omega by dt, right?
Yes, but
But let me just solve it back.
you need to acceleration is V square by R.
Yeah.
See, acceleration will be, if you need to compare it, there will be A1 by A2, that will be V1 square by R1 upon V2 square by R2, isn't it?
Yeah.
So I can write it V1 by V2 whole square.
So why can't we do d omega by dt?
Why you are putting d omega by dt? Where is omega?
You can find it.
Okay. So what is V? V1 is, see, the time period is same. Okay,
Okay, so
time period is same. So you can say V1 is equal to R1 omega 1.
yeah.
And what is omega? Omega is 2 pi t,
Yes.
isn't it? So omega 1 I can write it R1 2 pi t. As t is same in both the cases, so we'll put it R1 into 2 pi t. Okay. And what will be V2? V2 will be same way, R2 into 2 pi t. So that will also be taken as t. Okay.
So 2 by 2 can get cancelled.
So but what is V1 by V2? V1 by V2 is R1 by R2. So we can put that V1 by V2 here. So that is R1 by R2 whole square and multiplied by R1 by R2. So that is R1 square by R2 square into R2 by R1. R2 1 power cancelled. So that becomes R1 by R2. So that means third option is the right answer. Okay. Okay, very good.
Yeah, done.
Done. So now we'll move on to the next one. Yeah, this one. Just try to do it.
I'll just do what is the next step.
Yeah, please. That is very simple question, I think.
You just integrate this, right?
Yes.
You just integrate 3t minus t square. And then put the value of t.
It will be a definite integration.
What will be the, okay, it will be 0 to t, 0 to 2. Sorry.
Yes. Yes. Just do it. Tomorrow is Thursday. Tomorrow we'll also have class the same time.
Okay. Is the value 10 by 3?
Yes, right answer. Great. The value is 10 by 3. Okay, nice. Now do 11th. It's a conceptual question.
Which statements are correct?
Yeah. Simultaneously we are aired on YouTube, so if you want to see that lecture again, so you can go to YouTube.
Okay, sir. What question should I do next, sir?
11th.
I already said 11th.
What is the answer?
What statements are correct?
So tell me what statement are correct.
Both of them.
Okay, both of them. Okay, so both statement 1 and statement 2 are correct. Okay, great. So now the next question. Just give it a try. Cannot bear a tension more than 100 Newton means the maximum tension it can sustain with 100 Newton.
Okay.
How was your previous test?
My score was not good, but the paper was very difficult. So my rank was still 9 out of 72.
Okay, 9.
Yeah. No, okay. It was 9 out of 46. Sorry.
Okay,
And it was. One second.
and what it was in the previous paper?
It was 9 out of 47, and it was 48 out of 257.
Okay, so that means it is not increasing.
Yeah.
Are you doing it?
Yes, sir. It will be d theta by dt, right? Angular velocity. So, yeah, d theta by dt.
Where is theta and where is t?
Yeah, that's what I was trying to find. Like, how will I find the theta in this case?
Can't you simply use V is equal to R omega? Omega will be V by R.
Can you explain?
Yeah. Whenever your maximum tension, so that will be equal to the centripetal force, isn't it? Tension will be balancing that centripetal force. So your T is 100, M is how much? M is 100 gram. So that means 0.1 V square we don't know, R is 0.1 meter, 0.1 meter. So V square is 100. So that means V is 10 meter per second. And we know V is equal to R omega. So omega is equal to V by R. V is 10, R is 0.1. So that is 100 meter per, 100 radian per second. Wasn't it simple?
1 second. So, okay.
Okay. So option A is the right answer. Okay, now do 13th question. For your ease, that will be T1. Okay. T2 will be here and here. T3 will be here and here. Okay. That's also a good question. And all of three bodies will be going with the same angular velocity.
Yeah.
See, this mass will experience what forces?
This mass will experience, which mass are you talking about?
The first one, the inner one.
It will first experience an external force in the right direction because of the velocity.
See, there is only tension and centripetal force. As it is moving, as it is rotating in a circular path, so it will be having a centripetal force, okay?
Yeah.
And centripetal force is always inward.
Yes.
So that means the difference of T1 and T2 will give you the centripetal force of this one, this first body, okay? What is centripetal force? Centripetal force is mr omega square, isn't that?
Yeah.
Okay, so that will be equal to what is r in this scenario? R will be the length from center, so that will be L, it is given, so that will be ml omega square. So that is your first equation. What force the second body will experience? It will experience T2 minus T3.
T2 minus T3, yes.
Okay, and that will also be equal to centripetal force. T2 minus T3 will be equal to m, how much length it is? 3L?
Yeah.
3L omega square. So that will be equation number 2, isn't?
Yes.
And what this third body will experience? That will experience only T3.
But it will also experience the external force V which is acting on it, right?
All are moving with same velocity. Velocity will not be changed.
Okay, because the same string, that's why.
Yeah, they can't travel with different velocities. So T3 will be m into how much length? It is 6L. 6L omega square. So T3 is 6 ml omega square, isn't that? T3 we found. If we put the value of T3 in equation number 2, T2 will be 9 ml omega square. If we put value of T2 in equation number 1, then T1 will be 10 ml omega square, isn't it? We found T3 as 6 ml omega square. Put the value of T3 into equation number 2, you will get T2. T2 will be 3L m omega square plus 6 ml omega square, that will be 9. And if you put value of T2 in equation number 1, you will get T1. So T1 will be 10 ml omega square. So what is the ratio? T3, T2, T1. T3 is 6, 9 and 10. So option number 3 is the correct answer. Okay?
Yeah.
Okay. That's good. Got it. Okay. Now try to do 14. Tomorrow before coming to the class, you will have to try every question
From the other paper, right?
from this paper. This is not yet completed. It has 45 questions. Only we have done 13.
Okay, sir.
First of all, we'll finish it, then we'll go to the second one.
Yes, sir. So what formula will be used in this case?
See,
Omega square.
just note down what are the values given. Mass is given. Mass of the block is given to you. M is 2 kg. First of all, write down everything, whatever it is given. Distance is 1 meter.
Will it be 32?
The table starts rotating with constant angular acceleration. So, angular acceleration alpha about an axis passing through its center. Find the centripetal acceleration of the block. T is given as 1 second. You need to find centripetal acceleration. Okay, that means AC.
Yeah, I did put in the formula MR omega exponential these values, but then the correct answer not coming because for the 16 was a 16 was a 32, but 32 is not.
AC is R omega square, but you don't know omega.
We know, okay, we don't know. It must
Okay.
be
Omega will be omega 0 plus alpha t. Okay.
We didn't write this formula, sir.
These are angular equations. Okay. V is equal to V0 plus AT. Wasn't that? So that was linear equations. This is angular equations. Okay. Velocity will be replaced by angular velocity, and acceleration will be replaced by the angular acceleration. Okay. So omega will be omega 0 plus t. Omega 0 was 0, alpha is 4, t is 1. So that will be 4 radian per second. So omega you calculated. Now just put the value of omega here. R is how much?
MR omega square, right?
That is force. That is centripetal force. Mr omega square is centripetal force. Centripetal force. AC is R omega square only. Omega is 4. So 4 square. So that means 16 radian per second square. Okay. So that will be the answer. Got it? Now what is your work? You just finish, you just try each and every question from the exercise, from the paper, and if you have any doubts, whatever question you do, we will not discuss it, but whatever is left, we will discuss it. Okay?
Okay, sir. Yeah. Thank you, sir.
Okay then. Bye bye. See you.